Hello and welcome. In this video I will explain what the urban heat island effect is and how it happens. With climate change, extreme temperatures are more likely. This includes longer periods of high temperatures. Cities are especially vulnerable to these higher temperatures due to the urban heat island effect, which is a phenomenon that the city is generally warmer than its rural landscape. The urban heat island is most pronounced during the evening and night. During this time, the air temperature over the metropolitan landscape can show large differences. During calm and clear nights, these air temperature differences between the urban and rural area can easily reach up to 8 degrees Celsius. The urban heat island phenomenon is present in most urban areas, even in small villages. This is an example of the urban heat island in Amsterdam. In green you see the air temperature of the rural weather station increasing during the morning and decreasing in the afternoon and evening. And in red you see the air temperature in the center of Amsterdam. During the morning and the start of the afternoon there is very little difference between the two temperatures. However, in the evening and night the air temperature in Amsterdam stays much warmer than the temperature in the rural surroundings. The formation of the urban heat island is caused by various processes. So first of all, the city consists of streets with buildings. These buildings trap the solar radiation that enters the street. This energy eats up the buildings and streets and can hardly escape during the night. Of course, the city has other sources of heat as well, such as waste energy from electricity production, transportation, or heating and cooling of buildings. In addition, human metabolism, so people, are a source of heat in the city as well. Finally, urban areas generally have a lower fraction of vegetation cover. In rural areas, part of the incoming energy is used for the evaporation of water from plants and soil. However, since urban areas have more impervious surfaces, the energy that would be used for evapotranspiration is now used for the heating of the air and the surfaces. All these things combined can lead to higher air temperatures in the urban environment compared to the rural surroundings. Naturally, the strength of the urban heat island is determined by different variables, both from a meteorological and an urban form perspective. Variables such as clouds and wind have a negative effect on the urban heat island. Clouds decrease the amount of solar radiation reaching the urban surface, and therefore the amount of energy that will be stored in buildings. More wind induces horizontal mixing between the urban and the rural environment. On the other hand, urban morphological properties also influence the strength of the urban heat island. As we saw already, more vegetation in the urban landscape will allow more energy to be used for evaporation and leave less energy for warming of the atmosphere and the buildings. In addition, street geometry and the availability of open water surfaces also influence the urban temperatures. How exactly, I will explain now. When talking about geometry of the streets influencing urban temperatures, there are two important counteracting processes. First, there is the trapping of heat within the streets. In more open streets with low buildings, heat is stored in the pavement and in buildings can more easily escape. Whereas in narrow streets with high buildings, this heat is trapped and can hardly escape. This process is of main importance during the nighttime and enhances the urban heat island for streets with high height-to-width ratios. On the other hand, open spaces in a city receive a lot of energy from the sun during the day, whereas in narrow streets with high buildings, solar energy usually does not completely enter the street, resulting in a shadowing effect. This daytime process causes air temperatures to decrease with enhanced height-to-width ratios. Which of these processes dominates in controlling the urban heat island varies for different seasons and latitudes. For example, in the winter of the mid-latitudes, so cities like New York, Paris or Moscow, there is very little incoming solar radiation. For this reason, the trapping of heat is a dominant process determining the effect on the height-to-width ratio. This means that the urban heat island increases for narrow streets with high buildings. In a mid-latitude summer, we can see that the urban heat island can also decrease if we have a larger height-to-width ratio of the streets. This means that during this time, the shadowing effect is the dominant process. Now we will have a look at the influence of open water on the urban temperature. Water is thermally slow, so this means that it responds slowly to changes in the air temperature. Therefore, the temperature of the water varies very little throughout the day, whereas the air temperature can fluctuate more than 10 degrees Celsius. Adding open water in a city, therefore, reduces the daytime temperatures when the air temperature reaches values higher than the water temperature. But during the night, when the air temperature drops below the water temperature, the water has a warming effect, and open water enhances the urban heat island. So I hope you stay cool in your city.